Up next, we're going to be discussing systems of inequalities. Now, I kind of like this because we get to draw. But before we jump into that, let's make sure we understand how to graph an inequality to begin with. So let's take this guy. Y is less than negative 2/3 x plus 4. Now, before we jump into this, some things you want to make sure you understand. We're first going to graph this as though it's an equation. So we see this is something that's in slope-intercept form, so identify the slope, the y-intercept, and graph, get nice points. And then look at your inequality. So if you have less than or you have greater than, that means that whenever you graph, you'll be using a dashed line. And any points that you plot have to be open, because not being able to be equal to would indicate that you can't actually touch the line itself. And the line should normally be your solution set. But with inequalities, we're going to be looking at a region of the xy plane. If you have less than or equal to or greater than or equal to, that means that you're going to have a solid line when you graph. Now, if you can, solve your inequality for y. Because if you solve for y, and you have y is less than or y is less than or equal to, that means that you will shade below your graph. If, on the other hand, you have y is greater or y is greater than or equal to, that means that you will shade above. Now, if you can't solve for y, because there will be some inequalities that we come across where you just can't get y by itself, then what you'll need to do is pick a test point, typically something like the origin, to see if it lies within the solution set or not. Because typically you're going to have one side or the other of your graph. All right, so let's look at what we have here right now. We have somebody that has a slope of negative 2/3 and a y-intercept of 0, 4. Okay, so shouldn't be too bad. So the y-intercept is 0, 4. Keep in mind, this is going to be a dashed line, and it's also going to be shaded below. So dashed line means we can't put solid points. Sorry, guys. So 0, 4 is going to be right here. So 0, 4. And then I'm going to go down 2 and over 3. So down 2, over 3, down 2, over 3. I'm going to keep doing that until I get to the edge of my graphic window. And then go back. Up 2, left 3, up 2, left 3, and so on. Since this is supposed to be a dashed line, I will make sure that I do a dashed line going through these guys, making sure I put arrows on the ends because that's what you're supposed to do. Now, since this says y is less than, that means I need to shade below my graph. So no matter where your line is, if I say below, pick a point here, and below means going down from that, whether it's going down like this, going down like that, doesn't matter, go down. So below is going to be below the line like that. So I've got some things here that I can highlight with, so I'm going to highlight because I think that's kind of fun. So for us, it's going to be everything that is below this line. Now don't get too caught up with doing the shading where you kind of go a little bit too far, or you spend too much time shading trying to get all this stuff colored in. It doesn't really matter. So it means any point that is in this shaded region is going to be true when I plug it back into my inequality. So y less than negative 2/3 x plus 4. So it doesn't matter. And we talked about picking the origin, right? If I look at the origin, it's in my shaded region. If I plug in 0 and 0, is that true? Will that give me 0 is less than 4? Yeah, 0 is less than 4. So my solution set is not just the graph. It's not just a couple of points. It's every point that is in this shaded region. Anything here is going to work. Anything up to, but not including that line, is also going to be part of the solution set. All right, so now that we have the basics down, let's try our hand at some more difficult examples. They're really not too bad. Just make sure you know how to graph.